All right, we're going to skip over a couple of lessons, specifically 6.5 and 6.6, and we'll come back to those. And we're going to look specifically at the binomial theorem. And I love this lesson. Like, a little bit of my nerdiness comes out because I think it's just so amazing that somebody thought of this. And you'll see what I'm thinking of, or talking about. But basically, we're going to look at something called Pascal's triangle. This is not something that you need to memorize. But what we're going to do is say, okay, we've done multiplying perfect multiplying perfect squares together, where we said, okay, if you have a plus b, it's a plus b times a plus b, write it twice, and then you get a squared plus 2ab plus b squared. We've even looked kind of thought about this a little bit of a plus b quantity cubed, and that means you write it out 3 times, and then you have to FOIL this, and then you have to multiply it by this. But what happens when I give you a plus b to the 5th power? Because I might do that. Not because I'm a monster, but because I want us to be able to think about it. Well, this guy named Pascal came up with this triangle that helps us, because look at the coefficients of this. The coefficients here are 1, 2, 1. And the coefficients here are 1, 3, 3, 1. Well, look at your triangle that's here and tell me if you see anything interesting, maybe, about the coefficients of this, and your triangle. Maybe you noticed that 1, 2, 1 is this row right here. And maybe you noticed that 1, 3, 3, 1 is this row right here. So this guy Pascal came up with a triangle that gives each of the coefficients a row, depending on what our exponent is. But it gets even cooler than that, because I want to know, do you see a pattern in how he's coming up with numbers? For example, how did he come up with this 10 right here? Look at the 2 numbers above it, 6 and 4. 6 plus 4 is 10. If you look down here, 20 plus 15 is 35. 5 plus 1 is 6. 2 plus 1 is 3. 3 plus 1 is 4. Oh my gosh, this is the coolest thing ever. Okay, maybe my definition of cool is a little different than yours, but that's okay. And so this is how Pascal came up with this triangle, but he also saw that this pattern, when we're doing something quantity cubed, matches this pattern. This is not a triangle that you need to memorize. I will give this to you, but let's try it out here. So, hey, look, a plus b to the 5th power. So something that's important to note is that when we start counting the rows, we always start with 0. 1, 2, 3, 4. And you'll notice that this was a plus b quantity squared, so we looked at the 2nd row. This was the 3rd, so we looked at a plus b quantity cubed, and that's how we got those coefficients. So here's what we're going to do. There are several different ways you can do this. My way that I'm going to show you might take a smidge longer, but it's going to keep your work organized, and I think it's going to actually keep you from making silly mistakes. So we are going to make a table. I know, everybody's favorite thing, making a table in math class. And what we're going to do is we're going to put our first term here and our second term here. And it's positive, so I'm going to leave it positive b, but if it was negative, I would take that negative over with it. And then this first column is for the coefficient. Now, my exponent is 5, so counting from 0, I've got 0, 1, 2, 3, 4, and 5. So I'm going to look at this row right here, and these are going to be my coefficients, and I'm going to put them in order left to right. So I get 1, 5, 10, 10, 5, 1. Now, with the next column, we need to put them in descending order. In the second column, we put them in ascending order. So what that means is I'm going to have a to whatever this exponent is, and I'm just going to work my way down. So a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, and then a to the 0. Whereas the b, they should be going opposite directions. Think about like the escalators in the mall, and you see people going in different directions. One side is going up, one side is going down. Same idea here. It doesn't really matter either which one you put which one you put first. I just always do down and then up. So this one, I usually start from the bottom and work my way up. So I say, okay, I start with b to the 5th, again, because it has an exponent of 5, and then 4, 3, 2, 1, 0. All right, so we made our table, and it actually didn't really take that long. There are a couple little simplifications that we can make. Anything to the 0 power is just 1, so I'm going to cross those out and write 1. And now what we're going to do is multiply everything straight across. So I'm going to multiply this straight across. 1 times a to the 5th times 1 gives me a to the 5th. 5 times a to the 4th times b to the 1st gives me 5 a to the 4th b. And I'm going to continue that across. And then I get 10a squared b to the 3rd, 5a b to the 4th, and then 1b to the 5th, or just b to the 5th. There it is. All right, writing this all out though, this is like what our terms are going to be, but I need to write it as a polynomial. So I'm going to write it like this: a to the 5th plus 5a to the 4th b plus 10 a to the 3rd b squared plus 10 a squared b to the 3rd plus 5a b to the 4th, and then plus b to the 5th. Now, I know that that is still a lot of work, but think about it. If I did not give you this method and just said, hey, solve this, you would be writing it out, a plus b 5 times and having to FOIL and FOIL and FOIL and FOIL again. So this does go faster than if you wrote it out like this and had to multiply it all out. So this right here would be your final answer. I also just think it's really cool. All right, so what are going to be your coefficients based on your exponent? 0, 1, 2, 3, 4. Your coefficients will be 1, 4, 6, 4, 1. All right, in this first column, we're going to have our first term, and it's going to be x in descending order. And in the second one, it's going to be 3 in ascending order. So I'm going to have x to the 4th, x to the 3rd, x squared, x, and then I'm just going to go ahead and write 1 because I know it would be x to the 0, which is 1. So for 3, I'm going to get 3 to the 5th, 3 to the 4th, 3 cubed, 3 squared, and then, wait, sorry, I was thinking about the last one. So that should be 4, 3, 2, 1, and then 1. Because again, 3 to 0 is just 1. All right, so let's simplify these a little bit. 1 is just 1, but 3 to the 1st is just 3. 3 squared is 9. 3 cubed would be 9 times 3 is 27. And 27 times 3 is 81. Now, multiplying straight across, tell me what I'm going to get for these 5 numbers in order from top to bottom. I'm going to get x to the 4th, 12x cubed, because I'm doing 4 times 3. Here I'm getting 6 times 9, which is 54, x squared. 4 times 27, which would be 108, x, and then 81, and there was no x there. So when I write this as a final polynomial, what am I going to get? X to the 4th plus 12x cubed plus 54x squared plus 108x plus 81. This would be my final answer. All right. So here I'm going to have exponent of 5. So tell me about my coefficients. What am I using? 0, 1, 2, 3, 4, 5. I'm using this row right here. You can also look at the second number. Since it's a 5, it needs to be a 5 here. So I'm going to have 1, 5, 10, 10, 5, and 1. What's going to go in each of my columns, in the left column and the right column? going to have x, and in this one, it's a minus 2, so I am going to put negative, and we'll see that the negative does make a difference. So, in descending order, I would have x to the 5th, x to the 4th, x to the 3rd, x squared, x, and 1. And in ascending order, I'm going to put this in parentheses, especially whenever there's a negative, we want parentheses. Negative 2 to the 3rd. All right, let's do a little simplifying. Negative 2 squared would be positive 4. Finish off these last 3 terms. What do you get for these? Negative 8, 16, negative 32. So if I multiply everything straight across, I'm going to get this line here, and I get x to the 5th. Multiplying this line, I have 5 times negative 2, which is negative 10, and then x to the 4th. 10 times 4 is 40, x to the 3rd. 10 times negative 8 is negative 80, x squared. And then what are the last 2 terms? 5 times 16 would be 80x. And then multiplying these across would just be negative 32. So notice whenever we have a negative, it means that our sign should be alternating. Positive, negative, positive, negative, positive, negative. So writing this out, I'd get x to the 5th minus 10x to the 4th plus 40x cubed minus 80x squared plus 80x minus 32. That would be my final answer. So again, Pascal, I think it's super cool that someone came up with this because it is actually a shortcut from what it would be if we didn't have this method. But it does take some attention to detail and some organization. So just take your time and make sure that you're not making silly mistakes. Let me know what questions I can answer for you.